Hello friends, this is Rashmi Singh. Welcome to my channel Unraveling Science. Let's have a moment of science please. Today's topic is electric current and its effect. In this video we are going to learn about what is an electric current, electric circuit, components of electric current, heating effect of electric current, in which we are going to study about electric bulbs, LED, electric fuse and MCBs, magnetic effect of electric current. In this we are going to study about electromagnets and electric bell. We all depend upon electricity in our daily life. All our household devices are run on electricity. Electrical energy is the most useful form of energy as it can be easily converted into various other forms of energy such as heat energy, light energy, mechanical and chemical energy. Electric current. The flow of charges through a circuit is called electric current. The SI unit of electric current is ampere and it is denoted by A. The direction of electric current is convectionally from the positive terminal to the negative terminal of the cell. Electric charge. It is a physical property of matter that causes it to experience a force when placed in an electromagnetic field, as you can see in the picture. The charge can be positive or negative. The object with the absence of charge is referred to as neutral. Like charges repel each other and opposite charges attract each other. Electric circuit. It is a complete path for the flow of electric current. A circuit consists of electrical cell device, as you can see in the picture, which uses electrical energy, a switch to on and off, and connecting wires. These are called components of circuit. If any part of the circuit is broken, electric current does not flow through it. Such circuits are called as open circuit. As you can see in the picture, open circuit. If there is no breakage in the circuit, it provides a closed path for the flow of current. Such circuits are called closed circuit, as you can see in the picture. Now here you can see that the electric current can only flow through the closed circuit and not through the open circuit, because the path is incomplete. Components of electric current. Cell or battery. It is the source of current. It has positive and negative terminal. When two or more cells are connected such that the positive terminal of one cell touches the negative terminal of other, it forms a battery. They can be connected in series or parallel. As you can see in the picture, a cell is a single unit, whereas a battery is a group of cells. And it is symbolized like this in the circuit diagram. Now switch. A switch is used to open and close the circuit. When the switch is off, the circuit is open and no current flows through it. When the switch is on, the circuit is closed, allowing the current to flow. Electrical appliance. An electrical appliance is a device that uses the current flowing through it to function, like washing machine, oven, etc., electric bulbs, iron, fans, electric motors. Wires. Wires connect the elements of electric current. They are made up of material that are good conductors of electricity, such as copper. Circuit diagram. A schematic diagram that represents an electric circuit using standard symbol of components of the circuit, as you can see in the picture. This is the diagram for series circuit and parallel circuit to show how they flow. Current flows in series and in parallel. Now, heating effect of electric current. When electric current is passed through the conductor, it produces heat in the conductor. This effect is called heating effect of electric current. Example is electric bulb, iron heater, geysers, electric kettles, etc. All devices have a coil of wire called an element. This heating element is made up of metal alloy called nichrome, which is an alloy of 80% nickel and 20% chromium. Nichrome wires have high resistance to electric current and can withstand high temperature. When the appliance is switched on, the element becomes red hot and gives out heat. As you can see in the picture, when the switch is on, the bulb glows. The amount of heat generated by the metal or the conductor depends on the length and thickness of wire. What makes a bulb glow? The bulb glows due to heating effect of electric current. A bulb has a partial vacuum, argon gas, and a thin filament called tungsten. Tungsten metal has high resistance and very high melting point. When electric current passes through the filament, it quickly heats up to 2500 centigrade. At this temperature, filament begins to glow and emits light. Light emitting diode or LEDs. Nowadays, LEDs are used instead of bulb because they consume less electricity, they do not produce heat, they have very long life, and they are almost unbreakable. LEDs allow electric current to flow in one direction only. LEDs cannot tolerate even a small change in electric current, therefore require appropriate resistors which regulate the flow of electric current. Electric fuse. A fuse is the safety device made up of material with low melting point. It is used to protect the device and the circuit from excess electric current passing through them. How does fuse work? A fuse has a thin wire of short length that melts easily when heated. This wire is made up of alloy of tin and lead, which has low melting point and high resistance. When excess amount of current flows, the fuse wire breaks due to heating, which breaks the circuit so no current flows through it and the device and the circuit are safe. These days, miniature circuit breakers or MCBs are used in place of fuses. They are switches which automatically turns off when current in the circuit exceeds the safe limit. You can turn on the circuit once again. And you can turn them on and the circuit is once again complete. Now, magnetic effect of electric current. A current carrying conductor produces the same effect as produced by the magnetic field of the magnet. This effect is called magnetic effect of electric current. Solenoid. As you can see in the picture, they are cylindrical shaped coil that exhibits the same magnetic properties as that of a bar magnet. When current is passed through it, that's why they are called solenoid. As you can see in the picture, solenoid acting as an electromagnet here. What are electromagnets? It is a device that acts as a magnet when current flows through its coil. It is a temporary magnet that loses its magnetic properties when current is withdrawn from the circuit. As you can see in the picture, when the switch is on and the red light goes on, this become electromagnet and the pins get attached to it. And when it's off, they come off. Here is the experiment where we take a coil of wire around the big iron nail and connect it to the circuit. So when the current flows, this nail becomes electromagnet and attracts small nails. Like you can see in the picture, it is attracting small nails. Examples of electromagnets are electric bell, TV, radio, CT, MRI scanning, etc. Electric bell. The circuit of electric bell consists of a coil of wire wound around on the iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The coil is no longer an electromagnet, it no longer attracts iron strip, and the iron strip comes back to its original position and touches the contact screw. Again, this completes the circuit. The circuit again flows into the coil and the hammer strikes the gong again. And this process is repeated and this is how the bell rings.
Thanks for watching. Please do like, share and subscribe.